Okay, so today we're going to go over the brake pad gauges. I'm going to show you how to use these. You'll see they're color coded, and on there they have small numbers inscribed on there. You'll also notice that they're color coded, red being bad, yellow being like a caution, and green typically being a good brake pad. We'll show you how to use these. Also going to show you how to use the dial indicator set that I have here. How we set that up for measuring rotor run out. Now that you know how to use the actual dial indicator, as far as the increments on it, let's see how it actually applies to fixing or determining if something's good or bad. And there's a bunch of applications. I've also got a just a regular digital mic in this case to show you guys that has applications as well. So we're going to show you how that works out and go from there. Okay, so the first thing I want to do is let's just take a look. This is a brand new brake rotor for the car that we're looking at. So let's just look at a couple of things. One thing you'll notice is that the edges are completely smooth in this case. And we're going to compare that against the one that's on the vehicle that's worn a bit. But I think this is a better picture of what we're trying to do. Let me show you here. We have a brake pad, right? Brand new brake pad, and we have a set of brake gauges in this case. Okay, so the brake gauge is designed to go between this portion in the back that's metal that goes along here. It's called the backing plate, and then this is the actual brake pad material. If we lay this down and we were to stick our gauge in between the rotor and that backing plate, you can see here that the width of this fits in there. As the brake pad wears down, then only a smaller gauge would fit in there. So we're going to be able to put this down and check the actual brake pads on the car below. So keep in mind that this surface is what's actually contacting the brake rotor to slow us down when we're driving the vehicle. The other thing that we remember from our service information is the spec that we had related to the thickness. So sometimes we'll get a measurement of the backing plate and the pad for a new one. But more times often than not, what you're going to be looking at is the actual thickness of the brake pad. This is typically what would be done during an inspection. In addition, this car actually has wear sensors on it, these guys right here, and we'll show you where those are. But just so you get an idea, if you look really close here, there's a really small hole there, right? And that's where this little sensor piece goes in. This guy goes down in here and clips into place here. Let me just snap it in for us so we can see that. Like this, it rests in there and rides along with the brake pad. Now you'll notice that that hole that's there, pop this back out so you can take a good look at it. You got to be careful. These are somewhat can be fragile if we're not careful with them. If you look here, the hole rests right about there. You can see my screwdriver stuck in there, right? If we were to kind of gauge where that would make contact when the pad wears down, you can see on here that there is a width of about 3 millimeters according to this, right? And when we looked at our service information on ProDemand, we were given a spec of where it said wear limit, and that wear limit was very close to that number. So as we go through this, you'll start to understand as the brake pad pushes against the rotor and wears down, the sensor gets closer and closer to starting to make contact with the rotor. It's made of a soft material and just a wire, and provides a ground signal when it touches, which is what inadvertently causes the brake pad wear light to come on. So kind of important to know what's going on in here. And what we're going to do is we're going to compare what we see here against what is actually on the car, and we'll be able to determine if they're good or bad. Now normally you don't need to have a new brake rotor or pad to determine that. Just that I happen to have one. I think it's a little easier for demonstration purposes to show you where it's at. The other thing that we're going to be looking at, we're going to use our dial indicator. On our dial indicator, right, this guy, we're going to push it down against the surface here, and then we're going to turn this rotor, right, so that it rides against this end here, and we'll see as this moves. That's called rotor runout. That's the complete smoothness of this surface all the way around. So we want to see if it's wobbling in and out. Now with the dial indicator, we can measure a lot of different things. We could check bearings, for example, for play, for excessive play, or if they're tight enough or not tight enough with the dial indicator. And then the other tool that we're going to be looking at are the two different mics that I brought out. So the first mic, just want to show you what the pros and cons are of it. So the digital mic, I don't know what I did in my cover here for the battery, doesn't matter. But on the digital mic, we have a couple of things here. One thing is that we can switch between inches and millimeters on the fly, right, immediately without having to do any type of conversion or go into a conversion chart. So if we were to take a look at this rotor, for example, we could take this, open it up, and we could measure the width of this rotor. It looks like we got about 28.1, just quickly. Not trying to be too specific. That's in millimeters. Now we could take this and we could do this in inches as well. Okay, so that's the new one. The other thing that you'll notice is that we have the two ends here, and we can measure inner diameter. So for example, this has holes in the rotor where the lug nuts go through, or lug bolts in this case, and we could use this to measure maybe the width of that hole if we needed to determine how big the hole was all the way around. The other thing that we have here on this mic is a depth gauge. So we could rest this here, for example, we could scroll this down till it bottoms out, and then in turn it gives us a reading up here as far as the depth. So you get like three tools or three abilities to measure different ranges here, and you can do it both millimeters and in inches. The one downside about this mic in this case is in this application it works really well because we have a completely, or what looks to be a very completely true surface. So if we put this down here and measure across, because it's flat, it gives us a true reading. But more times, often than not, our rotors have what they call a lip on the end. And a lip on the end can be a problem because the lip will measure higher than the true thickness of the rotor where the actual brake pad wears, and I'll show you that on the car when we go down to look at it. So we have another style mic here. This mic is specific for measuring rotors. It has one very interesting feature. It has this sliding portion of it here, but again, it's metric. It says millimeters here in the corner. It also has two protruding pieces down here on the bottom, and the idea is if we look at this this mic, if we were to lock it down with the screw here, you'll notice that the 0 lines up with 0 and that the end is completely closed, so obviously that's 0 millimeters, or we get no thickness. So as we use this tool, what's really important is